Hello friends, welcome back. So this is our next video for applications of trigonometry. To start with, we'll solve problems, slightly basic ones of application of trigonometry. You can consider them related to state board, and then we can go for the same type of questions which we consider as an ICSE chapter, heights and distance, for the next video. So basically, application of trigonometry. Where is trigonometry used? In this, when a problem is framed, obviously it will be a word problem. We have to transfer it to a figure first. Now when you transfer it to a figure, the first and foremost thing which you should remember is that trigonometry is applicable only to a right angle triangle, not to any other triangle. Now where do we use it? We normally use it to calculate far away distance or an angle made with respect to a particular object. For example, you are standing on a terrace, you are observing a car parked on the ground. So whatever is your line of vision, you are going to bend down to observe that car. I want to calculate that angle. Or else you are standing on the ground, there is a plane flying, you want to calculate the speed of the plane or maybe the distance of the plane from yourself, then also we can go for trigonometry. So for calculation of this particular problems, we require two concepts. Angle of elevation. Now in all these problems, whenever we are going to draw a figure, please remember line of vision is very important. What is line of vision? Whatever you observe straight along the horizontal line is our line of vision. So when we talk about angle of elevation, say AB is line of vision. Now this vision of mine, I am going to elevate. I am going to elevate. So this angle which is formed is called angle of elevation. Angle of elevation. So this was my initial line of vision. It has moved to this. So angle BAC is angle of elevation. Second, angle of depression. Angle of depression. Say if this is my line of vision, I am standing on a terrace, this is my line of vision, I am observing a car below standing on the ground, I am going to bend down. It will create this angle. This angle formed is angle of depression. Angle of depression. So these two required. Now very importantly, please remember both these angles formed are with respect to line of vision. So when you mark an angle and when you draw a figure, you have to mark it with respect to line of vision. Okay. Now let us go for the problem. The first one. The question says, from the top of a lighthouse, an observer looking at the ship makes angle of depression of 60 degree. So we want the lighthouse A lighthouse will be represented straight line. The ground where the AB is my lighthouse, they say. An observer looking at a ship, so this can be the position of the ship. Angle of depression is 60 degree. Now obviously from the point A, an observer, we are observing the ship, right? They say angle of depression is 60 degree. If you mark this as 60 degree, then it is wrong, because that angle is not with respect to line of vision. For an observer standing at point A, first I will have to draw line of vision. This is line of vision. Line of vision is always an horizontal line. Now with respect to this line of vision, that observer is making an angle of 60 degree. So this angle will be 60 degree as per the given data. Further they say if the height of the lighthouse is 90 meter, so height of the lighthouse is 90 meter, find how far the ship is from the lighthouse. Means find how far the ship is from the lighthouse. So I have to calculate BC, the distance. So what all things we have considered should be mentioned. Let AB lighthouse. AB is 90 meter. C, position of ship. BC, distance of ship from lighthouse. Then AE, line of vision. Therefore angle EAC is, or else I'll write angle of depression is angle EAC. Angle EAC is equal to 60 degree. Now this line of vision will always be parallel to the base BC. AE parallel to BC. Therefore angle BCA will be equal to EAC. They are alternate angles. They are alternate angles. So this angle will also be 60 degree. Therefore angle BCA is equal to 60 degree. So in a right angle triangle, see, a lighthouse will always be perpendicular to the base. So in a right angle triangle now, I know 90 meter, I know angle 60 degree, I want to calculate the distance of the ship from the lighthouse, which is BC. So in right angle triangle ABC, 60 degree, opposite side I know I want the adjacent side, or perpendicular side I know I want the base. So I'll apply formula of tan. Tan theta will be AB upon BC. Tan 60 will be 90 upon BC. Tan 60 का value is √3. 90 upon BC. So BC will be 90 upon √3. Obviously I will rationalize So it is 90 into root 3 upon 3. Root 3 into root 3 is 3. 1s are 30s are 30 root 3. We should substitute the value of root 3 which is given in the question normally. If not, we can substitute as 1.73. So 30 into 1.73, 9150 and decimal point, that is BC. So distance of the ship from the lighthouse is 51.90 meter. I hope understood what we have to do and how we have to explain it. Maximum problems we will have to apply tan. In a few problems sine and cos also may appear. So basically what is important in any of these problems is the figure. If this is correct, then everything will go correct. If this is wrong, you won't get the answer right. Okay? So very carefully you should do this, explain it and then solve it. Let us go to the next one. Next question. Question says, two buildings are facing each other on a road of width 12 meter. Two buildings road of width 12 meter. B, C. Buildings, so perpendicular, width is 12 meter. From the top of the first building, which is 10 meter high, the angle of elevation of the top of the second is found to be 60 degree. So from the top of the first building, 10 meter high, elevation of the top of the second building. Now, obviously elevation means I can draw this line. But for A, I require line of vision. Then only I can mark an angle of elevation there. I can't mark the angle with respect to this. It is wrong. Please remember again, angle is with respect to line of vision. So for that, we will have to draw this perpendicular from A, which is our line of vision. Now, with respect to this line of vision AE, the angle of elevation to the top of that second building is, angle measured is 60 degree. This is 60 degree. So let us explain what all things we have considered. Let AB and CD be two buildings. Distance between two buildings is equal to 12 meter. So BC is 12 meter. AB, the height of first building is given as 10 meter. Whatever we have drawn should be stated. Draw segment AE perpendicular to segment CD. AE, line of vision. Therefore, angle DAE is angle of elevation. Therefore, angle DAE is equal to 60 degree. So whatever we know is stated. We know BC, we know AB, we know angle. What we want to calculate? What is the height of second building? I want CD, the height of second building. What I observe is this quadrilateral, in quadrilateral ABCE, this is 90, this is 90, this we have constructed 90, so obviously the fourth angle is also 90. Angle ABC equal to BCE equal to 90. Building perpendicular to ground. Angle AEC equal to 90. Construction. Therefore, angle BAE equal to 90. From a quadrilateral, this becomes remaining angle. In a quadrilateral, if three angles are 90, the fourth has to be 90. Therefore, quadrilateral ABCE is a rectangle. If it is a rectangle, obviously the opposite sides will be equal. So what I'll get? AB is equal to CE is equal to 10 meter. AE is equal to BC is equal to 12 meter. Opposite sides. So now we got this as 10, this as 12. From CD, I have already got EC. What is remaining is DE. To calculate DE, I know AE. So obviously, in right angle triangle AED, angle 60 is known. I want its opposite side or the perpendicular side, and I know the adjacent side or the base, which is 12 meter. So obviously I'll go for tan 60, which is DE upon AE. Tan 60 is root 3. DE I want to calculate, and AE is 12. AE is 12. Therefore, DE will be 12 root 3. 12 root 3. So it is 12 into 1.73. 0.76 meter. I want height of the second building. Height of second building is equal to CD, which is CE plus DE. CE is 10 and DE is 20.76. which is 30.76 meter. I hope everyone has understood. Again, figure plays a very important part. If this is right, everything will go correct. Let us move on to the next one. Question says, a storm broke a tree and the tree top rested 20 meters from the base of the tree, making an angle of 60 degrees with the horizontal. Find the height of the tree. A storm broke a tree. So basically, we have to draw a tree. But what is happening here? The dotted line is done purposely because that is the part which will be broken. It is written a storm broke a tree. So somewhere at some point that tree will break. And the top part, as said, the tree top rested 20 meter from the base of the tree. So this is 20 meter. This tree top will come to the ground. It is mentioned making an angle of 60 degree. So what is this will be equal to this, because that is the same tree top which will rest at the ground and making an angle of 60 degree. There is no angle of elevation or depression here. So this is what is given. What they want us to calculate is find the height of the tree. Means I want AC. Let AC is the tree. AB broken part of the tree. Broken part of the tree. AB is equal to BD. Angle BDC is equal to 60 degree and BC is equal to 20 meter. These two parameters are given. I want to calculate height of the tree. To calculate height of the tree, I know BC, I require AB, but AB is equal to BD. So basically I want BD from this triangle. So in right angle triangle BCD, I want the hypotenuse. I know this angle 60. I know its opposite side or perpendicular side. And I want the hypotenuse. So obviously I will apply sine 60, which will be BC upon BD. BC upon BD. Sine 60 value is root 3 upon 2. BC is 20 upon BD. So BD is equal to 40 upon root 3, which is 40 root 3 upon 3. We can substitute root 3 का value. .06 meter. We got BD. Sine 60 is given, rested 20 meter above. Okay. Now what we want? We want AC, the height of tree. You can write here. Height of tree is equal to AC, which is equal to AB plus BC, which is 23.06 plus 20, 43.06 meter. If it is kept in root 3, then root 3 will be there, but you cannot add because one is an irrational number, the other is a rational number. Okay, so I hope both are understood. Let us move on to the next. Next question. A ladder on the platform of a fire brigade van can be elevated at an angle of 70 degree to the maximum. The length of the ladder can be extended up to 20 meter. If the platform is 2 meter above the ground, find the maximum height from the ground up to which the ladder can reach. So, basically, this will be my platform. From this point, I will extend that ladder. A ladder, right? A ladder on the platform of a fire brigade van can be elevated to an angle of 70 degree to the maximum. Length of the ladder extended maximum is 20 meter. So 20 meter is the length of the ladder. If the platform is 2 meter above the ground, so this platform is 2 meter above the ground, find the maximum height from the ground up to which the ladder can reach. So basically I want to calculate this maximum distance. We can name it as CD. We don't know any other dimension other than these two. Now there is an angle made. So again I have to draw the horizontal line for that angle, because angle made by the ladder, it is given 70 degree maximum. It can be elevated at an angle of 70 degree, elevated. So we can mention AB, the platform, AD, the ladder. So AD is equal to 20 meter, AB is equal to 2 meter, angle of elevation of ladder is equal to 70 degree. So angle EAD is equal to 70 degree. Segment AE perpendicular to segment DC. To calculate CD, we require this as a rectangle. Any other dimension I have missed out, I'll just check. A ladder on the platform, elevated, the length of the ladder can be extended to 20 meter, platform is 2 meter above the ground, find the maximum height. Okay. So whatever is given is there for you. I have to first prove this is a rectangle. So same in quadrilateral ABCE, angle ABC equal to angle BCE equal to 90 degree, angle CEA equal to 90 degree. This is construction, this is perpendicular to ground. Therefore angle BAC is equal to 90 degree, which is remaining angle. So quadrilateral ABCE is a rectangle. Therefore AB is equal to CE is equal to 2 meter. Opposite sides. We know CE now. We require DE, which I'll get by this right angle triangle. In right angle triangle ADE, I want the opposite or the perpendicular side of this angle. I know the hypotenuse, means I'll apply sine DE upon AD. Sine 70 ka value is mentioned in the question. We can take it from the table also. 0.94 upon DE upon 20. So DE is equal to 20 into 0.94. 8810 point. Therefore, maximum height from the ground. So maximum height from the ground will be CD, which is CE plus DE, which is 2 plus 18.80, which is 20.80 meter. I hope this also is understood, almost on the similar lines, but this was not given or this was not given, the hypotenuse was given. That's the only change there. And on a value of an angle may be mentioned in the question, or we have to take it from the table. Next one, question number 5. Question says, while landing at an airport, a pilot made an angle of depression of 20 degree. Average speed of the plane was 200 km per hour. The plane reached the ground after 54 seconds. Find the height at which the plane was when it started landing. Height at which the plane was. So obviously, height of the plane, this is the position of the plane. AB is the height of the plane from the ground. This particular plane, they say, is making an angle of depression of 20 degree. Again, angle of depression will be marked with respect to line of vision. So this angle is 20 degree, the angle of depression, which I have marked. Now they say average speed of the plane, and the plane reached the ground after 54 seconds. Okay, so let us first write, let A position of the plane AB, height of the plane from the ground, AC, direction of plane landing at point C. Angle of depression is 20 degree. AE, line of vision, therefore EAC is equal to 20 degree. AE parallel to BC, therefore angle ACB is equal to 20 degree. Alternate angles. So this is 20. We know that angle. Also, two more things we have mentioned. One is speed of plane, which is 200 kilometer per hour, and the time is 54 seconds. So this distance AC, the plane has traveled in 54 seconds. We want to calculate height at which the plane was when it started landing. Means I want AB. Now to know AB, I require AC. I know the angle, so either I require BC or I require AC. Obviously BC, something which has nothing to do with the travel of the plane. I can't find it unless and until mentioned in the question. So what is there to be found out is AC, because AC is that distance which has been traveled by the plane in 54 seconds. From this, a unitary method we can basically follow. 200 kilometer per hour when the speed is mentioned means 200 kilometer distance is traveled in 1 hour. 1 hour means 60 minutes, or 1 hour means 3600 seconds. So we can state distance traveled in 1 hour is 200 kilometer. Distance traveled in 3600 seconds is 200 kilometer. So in 3600 second, 200 kilometer is the distance traveled. In 54 second, how much distance is traveled? Basically, that distance will be AC. So distance traveled in 54 seconds, which is AC, will be given by 54 into 200 divided by 3600. So cancellation, 1s, 18s, 1s, 3s. So it is 3 kilometer. Therefore, AC is equal to 3 kilometer. Now once I know AC, 20 degree angle we know, I can calculate the height or at which the plane is at the start. So in right angle triangle ABC, obviously I want the opposite or the perpendicular side. I am aware about the hypotenuse, so I'll go for sine. So sine 20 will be AB upon AC. Sine 20 का value is 0.342. AB I want to calculate and AC is 3. So AB is equal to 0.342 into 3. 62101. So AB is 1.026 meter. So that is the height at which the plane was when it started landing. I hope this is understood. In this question, figure won't be a problem. You can draw it. Explanation won't be a problem. This part, understand carefully. It is given speed. When speed is given, it mentions 200 kilometer is traveled in 1 hour. But here it is 54 seconds for this particular travel. So I'll calculate that much distance covered in 54 seconds, which we calculated as 3 kilometer. And then the answer. I hope this is understood. So this was related to our application of trigonometry questions from the state board textbook. Any queries related to this, you are free to post it in the comment. I hope you have understood the concept of application of trigonometry. The next video will have few more problems, but from the chapter named height and distances from ICSC textbook. Please do like, share and subscribe the channel. Right? We'll meet quickly in the next video. Till then, take care. Bye. Good day.